In this series of videos, we're going to talk about strings. Strings are an interesting thing in Java because they're not a primitive. Remember the 8 primitive types. 6 of them are numbers, 1 is a Boolean, and the other is a character. A character represents only a single character. So a string is a collection of characters, to be honest, but it's more than that. It's really an object, but strings are so common, we get some special privileges with them that we don't get with normal objects. So, well, technically it's an object. It gets a few extra things that objects don't get. So we're going to go through some of those extra things, and in several videos we're going to talk about how strings work. Our eventual goal is to take a file that looks like this, where you see a series of strings that are separated by some delimiter. In this case it happens to be a semicolon, and we're going to consider how we can cut that up into its pieces and then put that into an object of some type. So we've seen strings before. In our programs that we've seen a string literal like this. A string literal means a series of characters within quotes. So literally a string. We didn't have to assign that to a variable first. We just kind of defined it in line, which makes it a literal. We also know that we can compose strings together by using the overloaded plus, which is the concatenation operator. If at least one operand on either side of the plus is a string, then it's going to turn the other operand into a string and simply append both of those strings together. Okay, one other thing that we'll see is that if we do wish to create a string, listen, it is an object. It will go into a variable, but typically we've seen constructors. Just a moment. We've seen. Let me go to my vehicles here. Just a moment. We've seen constructors when we create a variable. A constructor is something that looks like this. Okay, so we call a constructor. We assign it to a variable. We get a little, this is one of the places where we get a little bit of advantage or a little benefit with a string, in that we can call a constructor, but we don't have to. So I'll tell you what I'm going to do. I'm going to make a new class here where we can do some experiments. We're going to call this string examples. Okay, and now if you remember from several videos ago, public static void main is kind of a magic method. It's a method where our program is going to start. When I started the string examples class here, it doesn't have a public static void main method. I can create one in NetBeans by typing in psvm and then tab, and it creates that public static void main method. Okay, now if I say foo, you see that's a string literal. I can save that to a variable by saying string foo equals foo. Okay. Alternatively, I could say string foo equals new string foo. Okay. That's a traditional constructor like we're used to. One second, let me comment this out. That's a traditional constructor like we're used to, like we've seen in Driver. Like this guy right here, where you have the new keyword and then an open and close parentheses. But with strings, we certainly can do it that way, but because strings are so common, we can shortcut it like we've done here. Okay? Then I can say string foo bar equals foo plus and then bar, like so. Okay, system out print line, foo bar, and then plus foo bar. Okay, and save. So what I've done here is I've used the overloaded plus sign. Overloaded means that this operator plus can do different things in different circumstances. If we have an integer on one side and an integer on the other, it's going to sum them together. If we have a string on one side and a string on the other, it will simply append those two strings to each other. If we have a string on one side and a number on the other, like an int or a double, it will automatically convert the int to a string and then concatenate that int with the original string. Okay, so I could say foo bar plus 1 plus 2 plus 3 and save. And now let's go ahead and play this. and you're going to see foobar 1, 2, 3, because it's concatenating these two together, making them a string. Then, because this is a string, it turns the 1 to a string, and then it works left to right, so it concatenates those together. Now, since that entire unit is a string, it turns this number 2 to a string, concatenates it all together, and then again with 3, and therefore we get foobar 1, 2, 3. So that's one thing about strings. Another thing about strings is that they are immutable in memory. And what that means is that if I said string foo equals foo plus bar plus 1, 2, 3, or sorry, let me take away the declaration here. If I say foo equals foo plus 1, 2, 3, we're not changing what's in this variable foo. There is a place in memory with FOO, and down here, when I'm modifying this, I'm actually making a brand new thing in memory, a brand new place in memory that has foobar 1, 2, 3. That might not be so obvious or so easy to understand, but one principle in Java for performance reasons is that strings cannot be changed. It will simply create a new string anytime we do something like append to a string like this. One caution there is that we're actually creating several strings here in memory. We're creating a string called foo, we're creating a string called foobar, and then because we're appending a 1 to it, we're creating yet another string, foobar 1, and then yet another string, foobar 1, 2, 3, and then yet another string, foobar 1, 2, 3, just like so. So the value in this variable foo is going to be whatever the last result is, but the caution here is every time we use this plus operator, we're actually creating a new string in memory. Nothing that really bothers us as a programmer. We just want to think about this for memory management reasons. I'll go ahead and save and run and just make sure that it still works as expected. Okay, because of that inefficiency of, well, it's actually an efficiency, but because of that method of creating new strings, we have something called a string builder. And that makes the string operation a little more efficient. We can say sb.append, and then we can say foo, and then we can say sb.append, and then we can say bar, and I'll put it in caps so we see it, so that we see it a little bit different from the string I did above. sb.append, and then we can say 1.append, and then we can say 2, and then append, and then we can say 3. Okay, and then finally I'll say SOUT, and we'll say foo bar string builder, and then we'll say SB plus SB. That'll be fine. I'll play this, and we'll see that we'll get a very similar result. Foobar 1, 2, 3, just like we saw here. The advantage of this option over this option is that this is a bit more efficient in memory. It's not actually creating a new string each time. Now, for our purposes in this class, it doesn't matter to me really which one that you use. It just is important to know that strings are immutable in memory. Once created, they can't be changed. Any change to the string will result in a new place in memory with that new string. That's all. Kind of silly, but that's all. So string is not a primitive. String is immutable. The plus operator is overloaded. We can create a string without calling a constructor. A string is any characters enclosed in quotes, and any characters are fine. It can be numbers, can be letters, symbols, spaces, can even be empty string. And one other shortcut we get with string is I said it's a class. It's something that's available to all of our programs automatically. Normally, if we want to use a class, we have to import it explicitly. We don't have to do that with string because it is contained in the special package called Java Lang. Anything in that package, or in other words, anything in that directory structure from the Java virtual machine, is automatically available to our program, and we don't have to import it. So when we're making the jump from primitives to objects, a string is a nice way to do that. So our goal here is to be able to split up a file like this and create an object out of it. But first we want to split it up into all of these strings. we want to split it based on the delimiter into each of its component parts. And what you see is each line here, 1, 2, 3, all the way through 16, each line that you see here is a different string or a different plant. This is essentially a feed of data that the Plant Places mobile application gets when you do search by color. So if you take a look down here, there's a search by color on the web page. This search by color also exists on the mobile application, but the mobile application has to get the data from plantplaces.com. So the mobile application is actually going to hit this URL, the one that you see here, and it's going to pass in some different color values. You might remember one of our very first videos, we talked about zeros and ones, and I talked about how they can be used to represent things from numbers to letters to sounds to colors to video. So what we have here is a simple color, red 255, green 80, blue 181, and then some kind of accuracy. And if we tweak these numbers a little bit, this is a live data feed, so we'll get different values down below. You see, as I change the number a little bit, we get different values. That's what the mobile app is going to access. The reason I bring this up is if you take a look at my YouTube channel and I sort by popularity, some of the most popular videos are about parsing JSON. This isn't exactly JSON that we're looking at, it's a flat file. But when we understand how to parse a flat file, parsing JSON will come naturally right after that as well. So this is going to build on something that is very popular and that a lot of people are looking for. So in the next video, we're going to take a look at some string operations, specifically one that is a bit confusing, and that is substring. So I look forward to seeing you then. Thank you.